Okay, so we're going to have a look at another question from the electromagnetism topic. Here we are told, or we're asked, an electron in an X-ray machine is accelerated from rest through a potential difference of 100 kilovolts before colliding with a target. We're asked to find the terminal kinetic energy, and then we're asked to find the approximate terminal velocity. Okay, so we need to note a few things down about this question. The first thing we need to know is we're dealing with an electron. The charge associated with an electron is about minus 1.6 times 10 to the minus 19 coulombs. This is just an approximation. And the mass of an electron is about 9 times 10 to the minus 31 kilograms. These are just approximations. You could use more accurate versions of these, but these will be fine for the purpose of the question. Now, find the terminal kinetic energy. So what we need to do is we need to work out the work done by the field on the particle. So we know work is going to be equal to the kinetic energy gained. So work is equal to change in kinetic energy. Because the particle starts from rest, the work will actually be equal to the final kinetic energy. So normally it would be kinetic energy final minus kinetic energy initial. There is no initial kinetic energy because the thing starts from rest, so work will be kinetic energy. Now we know work, in the case of electric fields, is charge times potential difference. So work is the charge multiplied by the potential difference, and this is going to be equal to the kinetic energy final. So find terminal kinetic energy. This will be the charge minus 1.6 times 10 to the minus 19 multiplied by the voltage. The potential difference is 100 kilovolts. So the potential difference V is 100 kV, kilovolts. That is 1 times 10 to the 2 kilovolts. So that is 1.0 times 10 to the 5 volts. So multiplied by 10 to the 5. So this tells me the work done is minus 1.6 times 10 to the power of minus 19 multiplied by 10 to the power of 5. This gives me minus 1.6 times 10 to the minus 14. Now, because we're after kinetic energy, this is not going to be negative. Right, we just have a negative here, and again, a common theme in these physics questions, we're going to use this in order to find the magnitudes. So we're going to take the absolute value of this, and we're going to say this is 1.6 times 10 to the minus 14, and this is the kinetic energy that we're after. So now, this is what we've got. We've found the terminal kinetic energy, and this is just an approximate value. So this was part A. Part B says find the approximate terminal velocity. Well, we know that the kinetic energy is 1/2 times mass times velocity squared. We know the mass because it's an electron. We know the kinetic energy, so we can find the velocity. So if we rearrange this for velocity, divide both sides by mass, multiply both sides by 2, we get velocity is the square root of 2 times the kinetic energy divided by the mass. So this will be the square root of 2 times 1.6 times 10 to the minus 14. You'll notice here that if we didn't make this value positive, because we're just using this to find magnitudes, if we did not make this positive by thinking about the setup of the problem, this square root wouldn't work, right? So sometimes you just have to do this. You use these to find magnitudes. Then once you've got those magnitudes, you think about the problem to determine what the sign is. So we have this multiplied by, so this is 2 times the kinetic energy divided, by the mass, which is 9 times 10 to the minus 31. 9 times 10 to the minus 31. Now this can go in our calculator. Square root of 2 times 1.6 times 10 to the minus 14 divided by 9 times 10 to the minus 31. This gives me 1.88 times the 1.88, this is a long string answer, 1.885 ... times 10 to the 8. So therefore the velocity is approximately 1.89 times 10 to the 8 meters per second when rounded to 3 significant figures. 3 sig figs. This is the answer after. This is unbelievably fast, very close to the speed of light. So tremendously fast. The particle is being accelerated very, very quickly. In reality, this is not quite right, because once you start moving that fast, the framework for analyzing speeds changes. But certainly using our electromagnetics topic, this is an approximate value that we can gain.